So we're back, and here we are reviewing application of trigonometry, both in right triangles and in circles. So the first half of this review can be found in the link I'll post here on the screen if you have not watched that yet. But looking at our first situation, here we go. So a man is located 200 feet from a point directly underneath an observation deck that is located on top of an office building. So we have an office building here, and we have this observation deck. We'll say it's right, like that. This man is 200 feet from the base of this building. The angle of elevation from the man to the bottom edge of the deck is 25 degrees and 37 seconds. So that's a nice line. That's a nice line. The angle of elevation to the bottom portion of the deck is 25 degrees and 37 minutes. I think I said seconds earlier. It's actually minutes. And then to the top edge of the deck is 30 degrees. Color. So to the top edge of the deck, it's 30 degrees. Okay, so what is the height of this observation deck? So we desire to know this height. So in looking at this problem, I've said this before, that if you have two angle measures in a problem, you will most likely have two trig functions to evaluate. So understand what each angle measure will give us. So first of all, neither angle measure, neither triangle having a hypotenuse length leaves us with using tangent. This is where you're going to be using tangent in both angle measures. The 25 degree and 37 seconds, that angle measure, when using tangent, that angle measure is only going to get us this portion. We'll call this y. It's only going to get us the height of the building. So that would say y divided by 200, opposite over adjacent. And then the 30 degree angle measure, so tangent of 30 degrees, the 30 degree angle measure is going to give us the whole height, call this h. So the whole height from the ground to the top of the observation deck, the opening of that angle measure is going to give us the h, so h over 200, opposite over adjacent. So forming a game plan. If I can find the total height and the height of the building, the difference of the two, so x is going to equal, our answer is going to equal the difference of the two, h, and we're going to subtract y. So for solving this, we know we're going to be multiplying 200 times tangent of 25 degrees, 37 seconds, and then subtract or multiplying by 200 over here, 200 tangent of 30 degrees. Okay, so evaluating each of these, we would get 200, we're in degrees, so we're good. 200 multiplied by tangent of 25, let's see, degree symbol, second apse, and 37 seconds, or minutes, enter, gives us approximately 95.8955, this would be, I believe, feet, yep, feet. And then for the height, 200 tangent of 30. And since there's no minutes or seconds, I don't need to put a degree symbol. We get 115.4701. So the difference of the two, so our overall height of the deck, will be the difference of the two. So we would have 115.4701, take away the height of the building, which give us an approximate height of the observation deck to be 19.5746 feet. So just like we've seen before, we drew ourselves the diagram, that's half the problem. We formed a game plan, we knew we had to subtract the two vertical lengths, and we performed the two separate trig functions to get our answer. So number 17. standing 120 feet from the base of a building, so, okay, 120 yards from the base of a building on the 8th floor, we notice that there's a window broken on the 8th floor. We know that one floor is approximately 12.2 feet. Okay, so I have feet, yards. There are 3 feet for every 1 yard. So understanding that 3 feet to every 1 yard, that would mean that 120 yards would convert to, multiplying this by 3, 360 feet. Okay, so 1 yard's 3 feet. So 120 times 3 gives us 360. So now we're going to be in equal feet, equal units. Okay. I've yet to even look at what we're asking for, but that's okay. So we know we're 360 feet from the base of the building, 8th floor, but every floor is 12.2 feet. So that would be 8 times 12.2 is 97.6. So 97.6, and we want the angle of elevation from my position to the broken window, which is right here. Angle of elevation. The only way we can get an angle of elevation, the only way we can get an angle is by using inverse trig. Inverse trig, we input a ratio and it outputs a angle measure. So not having the hypotenuse, we're using inverse tangent or arctangent of opposite divided by the adjacent, which gives us arctangent of 97.6 divided by 360, gives us an angle measure of approximately 15.1689 degrees. So knowing we want to find an angle measure, the only way of doing that is using arctangent. So number 18. Number 18, the Ferris wheel problem. All right, so we knew we were going to have one of these. So the Ferris wheel problem. The Ferris wheel in the figure below makes one complete turn every 20 seconds. From our previous video, we see that this is going to be our period. The 20 seconds is going to be our period. So when we think 2 pi over, well, they're using this, I think it's omega in Greek, we know this is going to equal 20. A rider's height, s, is modeled by this function, where s and k are given in feet and t is given in seconds. Okay, so solving for, we can do the period right now. So solving for this, we get multiply by omega, dividing by 2, we get, dividing by 20, we get pi over 10. It's simplifying. Okay. Now, K and A. Looking at A first. A is the amplitude. A is the amplitude without, and let's think of this without a vertical shift. So imagine that right now our x-axis is right here. If I had to plot the graph, that's our x-axis. This is our y-axis. Before we applied the vertical shift, that x-axis was going through the center of our Ferris wheel. The x-axis before the vertical shift is through the center of the Ferris wheel, which by looking at this, the radius of the Ferris wheel is 25. So you have 25 above and 25 below. And that would be our amplitude. So without a vertical shift, the highest we'd be is 25, the lowest we would be is negative 25. So our amplitude here is 25. So now what is our K? What is our vertical shift? So our vertical shift in this problem, okay, so I was down thinking of this. My lowest point is now positive 8. So my lowest point is now positive 8. My lowest point was at negative 25, as we saw from the amplitude. It was at negative 25. So if our minimum before this shift, if the minimum was at negative 25, and now the minimum's at 8, think of what vertical shift we have to apply. Well, how do you get from negative 25 to 8? You would have to add 33. So our vertical shift is positive 33. And with these three values, getting our period from, or getting our B value from the period, getting our amplitude from the radius of the circle, and getting the shift from the movement of our lowest point, we can see that our equation would be, our model would be, if they ask us to write it, 25 sine of pi over 10 t plus 33. Now would be the model of our equation.